Hello everyone, my name is Liu. It's my honor to give this talk for our work on unsupervised multimodal video-to-video translation via self-supervised learning. So we aim to learn video-to-video translation model that can translate the input frame sequence to the output frame sequence in a different domain. And the translation model should be generalized and needs to have the ability to deal with the large domain gap. For example, given a frame sequence of semantic labels, you are required to translate that into image domain. And the translated videos should be frame-wise realistic and semantic preserving, as well as temporal consistent. Previously, there have been a lot of works on image translation. Compared to that, video translation is less well explored. Besides the frame-wise realistic and semantic preserving requirement, just as also required in image translation, video translation need to additionally consider the temporal information. There is 3D RecycleGAN, which used the 3D neural networks to replace the standard 2D convolutional neural networks in image translation. However, the 3D temporal translator is kind of sacrificed the image quality a little bit. And there has been a RecycleGAN, which introduced the recycle laws to utilize the temporal information. But their methods lack the style control. As a result, the translated videos kind of shift in styles. As we can see from first frames, is translated to like the sunset, and gradually it turns to rain and translate back to the sunset. Besides, there's some considerate artifacts around the cars. So the reason is that first, their translator is simply the image level translator, which is widely used in image translation, first to capture the interframe information, and the temporal predictor for their networks is poor at capturing the motion information. Besides, they lack the style control to ensure the style consistency. So our work proposed to use the style control to achieve conditional video translation, which enables a very stable and style consistent video translation. Besides, we use the recurrent neural networks to capture the spatial temporal relationship across different frames. After that, we also introduced a novel video interpretation laws to chain the video RNN encoder-decoder networks in a self-supervised manner. So first, given a video frame sequence, we decompose the content and style to control the style formally. And we have a recurrent neural networks to propagate the interframe information to constitute the content used for translation and interpretation. And then we have some mechanics to show the style code to ensure like the frames within the specific video sequence share the same style to be style consistent. And we carefully design laws to enable joint chaining for modules. So we have video translation as shown in left. We also have the video interpretation task introduced to make a more stable translation in the highly complex video, unsupervised video generative adversarial chaining. So introducing a self-supervised task of video interpretation actually helps the networks to be more stable and utilize the temporal information better. These two processes actually are combined in a very organic way. And in terms of the result, our methods performs the best of all. As you can see, for like image to label mapping, we can achieve better semantic preserving performance. And for label to image mapping, we can achieve better FID for video scope, which kind of shows that our network is more style realistic and preserve the temporal information better. And you can see from the examples. So it kind of shows that our network produced the result which is more style consistent and content consistent. And besides, we have additional examples here, which additionally you can see like the result. And we can achieve some multi-subdomain, multimodality translation, which is very flexible. We also have some result on translating across subdomains, just as shown like rain and snow.